Hey guys, welcome to Unit 1, Day 11. Today we're going to be adding the final component of our ability to describe a graph today, which is symmetry. All right, so we're going to review what symmetry is. You probably learned a little bit about symmetry back in junior high, so we'll talk about that a little bit. And then we'll talk about integrating that into how we describe certain graphs, all right? And we're also going to learn how to write the equation for the line of symmetry. All right. So what does it mean for something to have symmetry? Well, simply put, it means that one half of the object is the reflection of the other half. So another way to think about it is if I were to take an object like this one here and I were to fold it, right? One half, so this half of the object, when I fold it over, would land directly on top of this half, right? So it would fold and you would get a perfect match going from side to side over this line of symmetry. All right, and that's what this dashed line is. It represents where would you fold this thing to get one side to land on top of the other. Okay, so this same thing here with the butterfly, right? So here's my line of symmetry, and if I were to take the butterfly and fold it over, everything on this side of the butterfly would fold over and land on everything on this side, and they would match up perfectly. Okay, so same thing over here. We got another example, right? So here's my object. We fold it in half vertically, just like this. And you can see if this half were to fold over, right, it would land perfectly on that right side. Okay, so sometimes it's called a mirror line or a fold line. So there's many different ways to describe it, but we call this the line of symmetry in Algebra 1. All right, so to get an idea of what that fold looks like, I want you to look at this GIF, and you can rewind and play this as many times as you need. So you can see over here, you can see the butterfly kind of unfolding, right? So you can see how that symmetry works. All right, so what does a line of symmetry mean for the graphs that we've been working with? Well, it means the exact same thing. It means that there's somewhere in this graph where I can draw a line, and when I fold over that line, I'll get one half of the graph to land on top of the other half. They'll match up. All right, so let's go through the things we already know how to do. So I've got a graph of a parabola here. We've seen many of these. Don't forget that the parabola does keep going up forever and ever. And let's describe some of these things we've learned about the previous day. Okay, so let's talk about the minimum, right? We're looking for the lowest point on the graph, right? So going up and down, I'm looking for how low I can go on the blue parabola. And that would be right here. Here's the lowest point. Okay, and that point is located at -3, -4. So I'm going to describe the minimum as this point, -3, -4. We also call this a vertex. Okay, so when we specifically for parabolas, we call the minimum the vertex, or if a parabola is opening downwards, we would call it the maximum or a vertex. Okay, now this one opens upwards, so we know that it goes off to positive infinity forever. All right, so that means it's not going to have a maximum. There is no high point, and sometimes on MyOpenMath, when you have that situation, you need to type in DNE. All right, x-intercepts, this is where we cross over the x-axis. That's this horizontal line that runs through the middle of the graph. Okay, so we have an x-intercept located here and here. We have two of them. There are two places where it crosses over. So this one is located at -5, 0. And then we have another one located at -1, 0. All right, now the y-intercept, right, that's where we cross over the vertical line that runs through the middle of our graph, and that happens right here. And the location of that point is at 0, 5. Okay, so we got all of these things. This is what we learned the last 2 days. Now we've got to talk about this line of symmetry, and I've got to envision where would I fold this parabola in half so that one side of the parabola lands on top of the other side. Okay, and that's going to happen here. And I'm going to draw it in as a dashed line the best that I can with my pen here. I suck with my pen. All right, so this is my fold line right here. And if I were to fold my parabola over that line, this side of the parabola would land directly on top of this side of the parabola. Okay, for our problems, when we do line of symmetry, we're only going to be examining vertical lines of symmetry like this. Okay, and when we write the equation of a vertical line, all vertical lines have the form x equals. And to figure out what number I'm going to put here, we have to look at the vertical line and see where it hits the x-axis. You see right here is my fold line. It hits the x-axis at -3. So I'm going to say my line of symmetry for this graph is at x equals -3. I have to write it as an equation like this. I cannot just simply say -3. I have to say x equals -3 if I want to get full credit. Okay? All right, now some graphs don't have symmetry like a parabola does. Okay, so this is a graph that actually does not have symmetry, and I'll show you what to do here. But first, we're going to go through all the other stuff that we've learned about. So we want to find y-intercept, x-intercept, min, and max. Okay, so y-intercept, right? Here's the y-axis. Here's where the blue function crosses over the y-axis. So that happens at 0, -1. Okay, so there's my y-intercept. My x-intercept, right, that's this line right here. Okay, so it crosses over and hits the x-axis here at 5, 0. And notice how I'm writing these all as points, right? X, y with the parentheses every time, right? Minimum, lowest point on the graph, right? So if I were writing my function like a roller coaster, how low would this roller coaster go? So if I'm writing it, I'm going down, 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 and then it stops. So this becomes my lowest point, which occurs at -3. Right? So it's at -4, -3. Okay, so this point right here, that is a minimum. Okay. Now maximum, right? Again, so if I were trying to get to the highest point on my graph, I would follow my function. It's going up, 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 up. And remember what this arrow means. This arrow means that it continues on forever and ever and ever. So it's going to keep going up. Even though it's going up slowly, it's going up a little bit, it's still going to go up forever and ever and ever, which means there is no highest point. So we're going to say none or D and E. Now, line of symmetry, we've already said there is no line of symmetry. There is nowhere that I could fold this graph and get one side to land on top of the other. Okay, you can try if you want to try and draw in a line of symmetry. So like maybe you try right here to say, hey, this could be my line of symmetry. And if I were to fold this over, right, this piece of the line would actually go like this, right? It wouldn't land on top of this section of our function. So this would not be a line of symmetry. And it actually would not matter where you put the vertical line, you'll never be able to get the left side to match up with the right side. So for this one, we would say D and E. There is no line of symmetry for this graph. All right, let's do one last one just to make sure that we've got it. So we're going to start with the x-intercepts on this one. Right, so x-axis runs left to right. I'm looking for where my blue function hits the x-axis. So it hits here and here. And I'm going to describe that location. So that's going to be 3, 0, comma, and then we've got another one over here at 7, 0. Okay, so if you have a problem on MyOpenMath where you have to enter in multiple x-intercepts like this, write the full coordinate of each one and separate them with a comma. All right, y-intercept runs up and down. Blue function hits the y-intercept here at -3. So we're going to say 0, -3. So there's our y-intercept. Minimum, okay, so I would go as low as my function would allow me. Okay, so I'm just looking at this side of the function. I know the arrow means it keeps going forever, so it's never going to stop going down, which means there is no minimum. So I would say D and E. And then I'm looking for a maximum, a high point, right? So it goes up, 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 and I get to here, and then it starts going back down. So this point right here, the point of this particular function, this is our max. And that maximum occurs at 5, 2, right? It's got a location just like any other point. Okay. So there's our maximum. Now, line of symmetry. And this one is tricky because we have to envision that this graph, even though this side of the graph looks shorter than this side, it's just because of the viewing window that we have for our graph. We know that this line continues on and on forever, and so does this one. So if we were able to see the entire function, there would be symmetry in this graph. Okay, and that line of symmetry is going to be right here. It's going to fall right on top of that max. Okay, so this would be the line that I fold over, and this line, which continues infinitely, would land right on top of this line, which also continues infinitely. So like I said, just because of the way that our graph is set up and where the graph gets cut off, it makes it look like it's not symmetrical, but it is in fact symmetrical. If we were able to expand our graph or continue this graph on, we would be able to see that symmetry plain as day. But because of the way it is cut off, it might trick you into thinking there is no symmetry. Okay, but since we know there is symmetry, we look for where that fold line hits the x-axis, and that fold line hits the x-axis at 5. So I'm going to say that my line of symmetry exists at x equals 5. Okay. All right, guys, that's it for today. Make sure you get those practice problems done. Let me know if you have questions in the Zoom chat. Have a great day.